So in this video, we're going to solve this problem, last stone weight. So what this problem is saying is that we have a collection of stones and each stone has a positive integer weight. And each turn we choose the two heaviest stones and smash them together. So suppose the stones have weights x and y with x is lesser than equal to y. The result of this smash is if the x is double equal to y, then both stones are totally destroyed, and if x is not equal to y, then we are going to calculate the difference between them and we have a new weight. Okay, so at the end of this, there is at most one stone left. Return the weight of the stone, and if there is no stones left, just return 0. So let's just see the example. In this example, the answer is 1 because so in this operation, we'll be picking the two maximum elements every time. So for the first turn, we are picking 7 and 8. We calculate the difference and we get 1. As it is not 0, that means we have a new weight 1, and we're going to insert that into the array. Okay. And the next time we're going to pick the maximum, the current maximum two elements, that is 2 and 4. We get the difference as 2. Then we're going to insert that into the array. Okay. Then we again do the operation, we pick 2 and 1 as the max because they are the two maximum elements in the current array. We're going to calculate the difference between them, that is 1, and we're going to insert that in the array. Okay. Then we are again going to pick two maximum elements, that are 1 and 1. We get the difference as 0. Then we are not going to insert 0 into the array, and we are left with only one element in our stones array. Okay. Then we're just going to return this because our condition is if at least one element is left, then just return. Otherwise, if nothing left, just return 0. So how do we actually approach this problem? So if you think of it logically, um, if we just think of naively, okay, so we have an array and we have to pick two maximum elements every time, and we have to do this process until and unless our array is empty or we are just left with one element in the array. So to maintain this, to get two maximum elements every time, you have to sort this array, pick two maximum elements, get the difference. If the difference is not 0 in the worst case, because we are considering worst case whenever we think about a problem, so we are going to calculate the difference between them, and we again going to insert that in the array and maintain the order, and for that we again have to sort this array. Okay, so this is just extremely inefficient. So what we could think of is, why don't we have a data structure that would give us two maximum elements efficiently, and we don't have to maintain this order of maintaining all the elements. So what is this data structure? This is known as MaxHeap. So what we can have is we have a MaxHeap of these stones. So every time we are going to pick two elements from the MaxHeap, calculate the difference, and if the difference is greater than 0, obviously we are going to insert that in the MaxHeap, and it will balance the tree. Okay, we don't have to worry about maintaining the order every time. We're just going to use a MaxHeap. Okay, so let's jump into the code. I'll just explain it to you. So we're going to build a MaxHeap first, right? So we build MaxHeap using a priority queue in Java. Priority queue of integer, and we name it MaxHeap new priority queue of integer, and we're going to calculate the difference between, because it is a max heap, we are just going to the comparator would be b minus a. If it is a min heap, the comparator would be a minus b. Okay, so now we're going to insert every stone into the max heap. So we're going to iterate over the stone array and insert stone into the max heap. Okay, so now after in building this max heap, what we're gonna do is, until and unless the max heap is empty or only one element left, we are going to do this operation. So while max heap dot size is greater than 1, we're going to do this operation. So what the operation is, we're going to pick two maximum elements every time. So int first, so this is the first maximum element, max heap dot remove. This is the first max element. I'm just writing over here, commenting it. And then the second maximum element, that is max heap dot remove, again second maximum element. And then we're going to calculate the difference between them. First minus diff is equal to int diff is equal to first minus second. Now I'll just check if the difference is greater than 0. If it is greater than 0, then we're going to again insert into the array, insert into the max heap, obviously. Yeah, difference is greater than 0, then you're going to insert that into the max heap dot offer, that is difference. If it is not 0, not going to worry about that. Then the max heap will run and just get the first and second and again do this operation. Okay, until and unless the max heap is 1, only will lift with one element, or the max heap is empty. So now I'll just check if max heap dot size is greater than 0. That means we are left with one element. Then we are going to just return max heap dot remove. Otherwise, just return 0. That's it. Just run it. Okay. Max heap dot remove. Okay, sorry, I haven't given the semicolon. Okay, it's working. Let's just submit that. Yep, that's working. So see you in the next video.